Hello and welcome back. Just before Christmas, so I thought let's finish this drawing part. Uh, yeah, yesterday, well, for me yesterday, I'm not sure when I'm gonna release it, but in the last episode, we ended up here. We had the screen initialized. It's nice and yellow, and like right there, and it says "Hello World." Might just be able to make it out, and what we did, we set up the display. Right, the display was initialized with all the code, whereas also the "Hello World" and the yellow background and everything. Then we created a service or like a task that we passed the display to, and here we could start doing things. On the other side, we dealt with the web service part, so we ended up making an endpoint where it takes a shape, and we made sure that all the deserialization was handled from JSON. We created the shapes, so we had a shape that was enum. Where's the enum? Yeah, right here. So it's enum shape, triangle with 3 points in this case. But yeah, of course we can add variants to the enum and also maybe to the supporting classes. But and here we define the from request, where we basically explain to the web framework how to create a shape from a request, and that's basically by taking the body and parsing the JSON, and because it has a derived serialize, that should work out. So that so now what we need to do is actually draw to the screen, and secondly integrate the two parts in a sensible way. So let's start by testing if you can actually draw to the screen, because right now we didn't do anything. We just have the display here, and let me show you how to actually draw something on the screen. There are some primitives in the embedded graphic library, like triangle, and you can make a new, and you have to put in 3 points. I'm not entirely sure by heart how it works, but I suspect something like this. Yes. So let's add some coordinates. 10, 10. So the screen is 240 by 534. So I don't know. As long as it's sort of out there. And I don't know, 240, and let's call this 200 as well. So this would create a triangle, right? But that doesn't really tell anything how it would actually look. What we need to do then is to call into styled and add a style. So what does a style look like? We create that with a primitive style builder, new, and then we can say like the color of the background or the strokes or the whatever. So we can, for example, do fill color is RGB 565. So that's the color space we're using on this screen, and we take blue, and we can do the stroke color, and we take RGB red, and we do the stroke width, for example 7, and we build the thing. So now we have a style, and now we can do the into styled, and once we're into styled, then we have a thing that is drawable, and we can draw it to the display, the mutable borrow to display. And I think we need to unwrap it then. Something like this. Cool, let's see. There it is in all its psychedelic glory. Yeah, something like that. So now we know that the screen works. Let's remove the hello world text. Also, the yellow is a bit much. Let's make it just black. To clean it up a little bit. So from here, so now we know we can actually draw on it. And now we need to think about how to actually integrate it. Because how do we get those shapes from... why isn't it working now? Did I mess something up? That is weird. It looks like somehow that matter. Anyway, to continue my thoughts, so how do we get the shapes from the web framework to the screen? Because we don't really call it. We don't really call the that sure is weird. So somehow this one was important. I don't see why. Let's see it one more time. I don't see any kind of possible race condition. So this works. And if we make it black, where is it? Can't imagine that's a problem. That works. Oh, I removed the orientation, that was it. Or did I? I'm not sure. Let's put it in portrait anyway. It's a bit easier, I think. And let's see if we can remove this now. That's a interesting twist. So somehow if I remove this, it doesn't work anymore. I need to get into that. I don't want to do it right now. So now it should have a black background and still work in portrait mode now. So let's verify that, and then this mystery is for another time. Okay. And the text we'll just need to ignore. Coolio. So how to actually do the drawing, because we end up with this task. It's not a method. It's not something it gets called here on initialization, but we don't call it afterwards. The way I want to do it is a way I've done before, using the primitives from the embassy, from the embassy sync crate. Let me show it. Sync, and there are some primitives on how to collaborate between different parts, because we are communicating between tasks that basically are on their own timeline, even though the actual they're not actually parallel now, because we're running on a single core, single thread. But there are some nice primitives here. So the one I used before was a channel. So you have like a beginning and an end. So some on one end you can put message into the pipe, and on the other side you can put it out. And the pub sub channel, for example, where you can broadcast different things to different that you can have multiple producers publishing to all the subscribers. So there are several ones. Right now we only have one producer and we also have one subscriber, so in that sense it doesn't really matter that much. But let's for now take a look at we did a channel before, so let's do the pub sub channel now. So what I want to do in the main somewhere, create a pub sub, pass the publisher to the website, and pass the subscriber to the graphics task. And whenever the website schedule pushes something into the pipeline, then the graphics will pick it up, and they don't need to lock a shared data structure or something like that. We just have this kind of streaming worldview, and I tend to like that. Okay, so what does that look like? Let channel. Yeah, it's a pub sub channel, but it doesn't matter that much. Pub sub. There it is. New. And that takes quite a lot of things. 5 even. So there are 5 generics, so that we need to somehow provide in the channel we want to create. So let's see if I can point to it here. Here we have M, which is the mutex we're using. As we're running single core, single threaded, we can use a no-op mutex. T is the type of the message we want to pass, so in our case that's a shape. These last 3 are because Embassy can run without an allocator, and running without allocator is basically that the microcontroller initialize memory only at startup, and for the rest it uses the same memory. So for that you need to indicate how big things can get, and in this case the cap is the size of the does it say it here somewhere? It's the size of the how many messages can be in flight. Subs is how many subscribers can exist, and pubs how many publishers can exist. So as we are running with an allocator anyway, you can't really decode JSON without it. But it makes it a little bit more complicated, but not an awful lot. So let's start with no-op raw mutex. The message we want to pass is actually a shape. The size of the queue 5, and let's, I don't know, just some number, doesn't really matter. We could also use 1. Let's make it a little bit prettier. Let's make constants for that, because this type we will be passing around, and that will get a little bit messy otherwise. So we can say const, what was it called? I call it Q cap, and that's U size, I suppose, 5, and we do that for the others as well. Const subs cap U size 2, and it has to be const because all this is resolved build time, not runtime. So pubs cap U size is 2, and let's put them up here somewhere. Make them public as well, so we can use them from other modules as well. Okay, so this is then qcap, subscap, and pubscap. All right, so now we can request publisher and subscribers from it. So for example, we can say let publisher is channel dot there is something wrong. I misspelled U size. So now we have a result of a publisher, so let's unwrap that one. And now we have a publisher with the same generics as the channel has. So let's pass this publisher to the web component. So here we have the web task, and we pass the publisher. Then we go in here, and we add here the publisher, and that's publisher with a bunch of generics again. Let's say static for now. I think it needs to be anyway. The no op mutex, no op raw mutex, shape, and q cap. I think we called it. We need to import it. Subs cap and pubs cap. And import those. Okay, let's check which one was first. Subs is first, yeah. So that's correct. Let's see, is main happy with that? So yeah, something interesting happened now, because in the web task, in the parameters here, I said it needed to be static, and now all of a sudden it's reasoning back that apparently the publisher needs to be static, so the channel should be static as well. So let's just make it static here. Make static basically just leaks the memory for it. What's it complaining about now? Oh, I did something dumb. I put the make static here, of course. So it basically leaks the memory, but as the the microcontroller will never give up the memory anyway. It doesn't matter. So now I have a mutable reference to it that will be static, and now this one is happy. There are some extra hoops to jump through to make this all work, because we were using this web state, if you remember, and the web state is a data structure that you can request in any route to be present. So right now we only have the shape, and we implemented the from request, so it knows what the shape is, and now we have 0 state in managing this request. If you can get away with that, that's the easiest, but often you can't. Maybe like let me remove the camera for a moment so it's not in the way. So often it's like a database connection pool or something like that. Something you rarely can get away with a totally stateless handling of requests. So what you can do then is to add a state object, and you tend to do something like this. You say state is state web state. Need to import that. And then it's kind of happy. And this is quite a weird thing to say if you're not familiar with Rust. So how PicoServe works, so that's the web framework we're using, similar to Axum and Actix as well, I think. So it will do some macro magic to make sure that both these signatures are acceptable, so with a state or without a state. You can also request other parts, maybe like headers if you want to. So this is what we get. We get the state object. The state object is part of PicoServe, containing the type of the state we defined. So that's here we instantiated the empty thing, and we called it with run serve with state. So then we pass in the state, and so this is what we get. So we could do this, and now we have that state thing, and what we can do is take our state object, so the web state object, out of it, but we can deconstruct it straight away because we know this is the only thing we're interested in. So it is a sort of indirect way of instantiating variables, which I think is kind of cool, but it took me a while to get used to the look. Like, this is a parameter definition. What the hell is happening here, right? Why is the left side of a parameter look like a function call? It's not a function call. It's just a deconstruction. So if sometimes there are multiple parts of it, and then you can deconstruct all of them. Anyway, so now we have a state object here. It's kind of useless because the state object here doesn't contain anything. Important, what we need to do, and there's kind of a rule that that anything we use as a state object is clonable. So that because we don't get a shared instance, that wouldn't work with the memory guarantees. So the framework will copy them as much as is needed to serve the request. However, some things we can't copy. In this case, the publisher is not clonable. It's a socket in a sense. It's something that has meaning. And if you clone it, then what would that even mean? So we need to put the publisher inside the web state, but if we do that, it's no longer clonable. So what we need to do is to create a field here, and the easy way would be this, but that doesn't work with clone. You see here that it says clone is not implemented. So what we then need to do is to arc mutex it, which is kind of a very common thing in Rust. So we put it in arc, we put it into a mutex. It's all slightly different than in regular Rust because we don't have the standard library, but not that different actually. So need to do some importing, I suppose. Alloc arc, so that's basically the same as the standard one. This one is from Embassy, so it's a little bit different, and that needs another, that also needs the actual mutex. So there we can do the raw no op. No, what was it? No op raw mutex. That one. So with that, so an arc is a reference counter. So we can copy the arc, then we can have two of those because who cares? It actually contains the same one thing. However, we need more than that because we want to publish something, and publish is a mutable operation. We are going to change the publisher inside here. So we also need a mutex to gain entrance to it. Anyway, let's see how that goes. Here we were constructing this thing. So now we need to add the publisher. And we need to create the arc, new, mutex, new, and the publisher. Does that work? Yes. So this is in a loop, and it wants to be able to do that over and over again. It can't because it will pass the publisher inside the original web state object. It's clonable, but still we can pass the publisher in only once. So we need to move this up before all the loops begin. And we put it here because that's all we need. Yeah, I guess it doesn't need to be mutable anymore. And now this state does contain anything useful. We do need to do some work still to put the state, to publish the shape into the publisher, which is inside the state. So state dot what did we need to do? We need to get the publisher. And then we have the publisher, that's the arc, and then we can skip that one, so we need to lock that, and then so because we want to have exclusive access, because we were going to mutate it, a lock is async operation, so we need to await that. And once we actually have the publisher because we managed to get hold of it, and then we can do a publish. And what do we publish? We publish a shape. And I suppose we need to await that as well. And then, is there an unwrap here? No. So that's basically it. And we reply something. It doesn't really matter. But we post the shape into the publisher. And yeah, from there we can do it a few times. Now if we would run it now, we can do it only, I guess, 5 times or something like that. What did we say here? Yeah, 5 times, because nobody is reading it. And then it will just stop accepting messages. Let's do the other side. The other side is the subscriber. Where did I make the thing? So let's create a subscriber. Channel.subscriber.unwrap. This one is, I think, a little bit easier because we don't need to deal with the state model, so it doesn't need to be clonable. So we can just pass the thing, subscriber, and we need to add here a subscriber. With all the things, static again, no op rom mutex shape, q cap, subs cap, and pubs cap. So this now does one single thing and then terminates. That is not really how it's supposed to work. Generally, these tasks will have some kind of loop, then do something that awaits in some way, and then just keep going and never really exit. And what we do in the loop, of course, is subscriber dot next message and await that. So now we wait until there is a message. It's a little bit more complicated than you might expect. Okay, so we still need to make them mutable, that makes sense. And it's a wait result. So there might be a message, there might not. No, that's not quite true. If this one completes, there is always a message. But there might be, it might have lost messages because like there is a, it pops up, so it's, if you have one very fast subscriber and one very slow one, either it needs to stop accepting messages until all the subscribers has caught up, or it needs to drop messages. And this is the difference between the channel and PubSub, that this one will just drop messages if there is a slow subscriber. So that means that we need to match on this, and then we need to deal with all the possible outcomes. And there are two here, so either it's lagged. Now in this case I don't think it's gonna happen, but who knows. So don't really need to do anything here. But when we do have a message, we can deconstruct it here. Let's call it shape, because we have a shape now, which came out of our subscription. So then we need to match on the shape. And we need to deal with all the variants here. We only made one, which was the triangle. What happened there? Too many somehow. Yeah, I think there is something weird with the code generation for the match arms. Then I end up with more braces than I should somehow. But I think we're good now. So now we have a triangle that gets deconstructed with 3 points. So here we can do our actual drawing. Let's see. Well, we made a triangle here. So let's go here. This style, I want to keep it a little bit simpler, make it green and no stroke. And let's see, so we need to create a point. So what I wanted to do was a dot x, right? Oh, it's private. I need to fix that in shapes. So that's this data structure, right? And we can get all fancy with all kind of accessors, or maybe an into point that we can just call into on it. That makes it a bit prettier. But gonna keep it simple. It says now it's a U16 and it expects the I32. Thinking about it, I think it's better to just do I32 because I can imagine negative coordinates to be at least able to represent them makes sense. And it's a 32-bit anyway, so we're not saving much. So now I think this one is happy. So then we need to continue a.y and b.x, b.y, and c.x and c.i, y. Okay. So that is that. Yeah. Let's see if it works. So now it doesn't draw anything on startup, which is what we expected. And now we are going to go to Postman, which is a HTTP client. And we're gonna post to this is the IP and my number, this is the endpoint we had, shape. And we're gonna create a triangle on the screen. Oh, I do need to switch off the camera then. Switch on the camera. Let's see. And there it is. A nice green triangle. If we, I don't know, do something else, then it should do something else. Yeah, it crossed over the edge now, but so that works. We can draw on it now. So that's basically it. I want to add a little more nice things to it. So one thing you might have spotted is that it's actually kind of slow when drawing. You see the drawing update. That would be nice to improve that. You can improve that by using a frame buffer, so that you basically draw on a separate piece of memory and then you just throw that memory at once to the screen so you don't get flicker. Last time we showed the GIF of the crab. That was kind of smooth. You didn't see the screen tearing you can see here. However, frame buffers are big. They take up a lot of memory, and the fact that this board has such a nice and high resolution is kind of annoying now, because it doesn't fit. I can't make a frame buffer of the entire screen in memory. I can only take part of the screen, and with a crab you couldn't really see that, but the crab was actually using like a little bit over half the screen only. There was like white borders above and below it, so it just made it. But yeah, that will eat up pretty much all memory you have. So if you want to animate things on this screen, you need to really create a small area of the screen where where you're doing the animation and create a small frame buffer there. Anyway, other thing is I would like to draw more than one shape at once. So I'm gonna expand that a little bit. The frame buffer I'm not gonna get into today. So let's continue and see what we can do to get more than one shape, because I think then the power of how we program it gets a little bit clearer. So let's go back to shape. So yeah, and also let's make more than one shape then, because that's a little bit too much. Yeah, this is a bit too easy. So let's add an ellipse as well. Start in the top left, which is a point, and it will take size, which is of type size, and I'm using the wrong braces. Size, very similar to point, only it's not signed. You can't have a negative size, and this just to make it easier on using the actual APIs, because then it matches. You can always cast it last minute, but it's easier to get it right the first time. So now we added this alternative, and then you'll see that you get immediately a compile error here that says basically that we didn't deal with that eventuality, and that's what Rust is all about. So we can add it here, then it will completely mess up the formatting. Let me just copy it and undo it. Something wrong in Rust Analyzer, I guess. And then we do it like this. So we have our ellipse now, and so we take ellipse, the primitive, new, it's not yeah, to be clear, this point and the point I defined are not the same types, right? This point I'm talking to now is part of the embedded graphics, and the other point was just one I made just for the sake of deserializing. So that's not the same. So I do need to do this, even though there are probably prettier ways to do this. Something like this, and yeah, of course, and then we do size, new. I guess it needs to be important. From the embedded graphics, and it needs to take size.x and size.y. And then let's give that an other style. And make that one yellow. So then we continue here. We just add this part, it's the same, only we're gonna replace the style with the ellipse style. So let's see if that works. How much time? I'll try to keep it under an hour. Okay, it's listening. So let's, I think it's then ellipse, top left is that, and then we need to say remove this one, and then size, I think as good as any. Let's see what happens. We went a little bit out of bounds here, so yeah, let's move it in a little bit, and a little bit smaller, so something like that, circle, like that. So now we can do ellipses and also undo all of that, a triangle again, and we can just keep drawing. Cool. Now the last thing I want to do is to do multiple shapes, because right now we have only one shape, and what would it be like if we would, for example, post an array of I mean a JSON array of shape objects, and I want to add that because it's kind of nice. So let's create a struct, and we call it shapes, so plural. And in that shapes we put on one vector of shape, right? And we need to import vector from alloc. Okay, and then we will need to implement the from request as well, because it's a different type, and we need to be able to say, okay, that shapes object, how do you create that from a request? But I think it's pretty much the exact same thing. Of course, we do need to say that shapes is deserializable. It doesn't need to be copied though. Can't be copied even. Debug is also not really needed, but and oh yeah, and we can underscore this one, so we get access to the state object, but yeah, we don't need it for the parsing. So let's clean up that warning. And then in our web we can create an extra route. Post shapes, for example, plural, and we're gonna say no, instead of shapes, a shape, we want shapes, and we need to import that. We can print it out if you want to, because it implements debug, so that's nice. And then we can do the extra trick, the same deconstruction trick we use for the state. So if you're not familiar, so this is a tuple struct, so you can have multiple items in the struct, but they don't have a name. And usually you use that if you want to deconstruct, because that makes it really nice. So what I can say is shapes, and then the first thing. So now it's private fields. Okay, I need to make it public. So pub. And now this shapes thing refers to the vector itself, because that's the only thing I'm interested in. It's the only thing that's there. So now I don't need to say shapes.0 or something like that. I just have the vector now. So what I'm gonna do for shape in shapes, I just loop around it and I publish all of them. So that's the multiple one. I need to still include that route, so let's do that. Let's do post shapes, and it seems happy, so let's have a look if it works. I'll reset the controller to clear the screen. I could make a command for that, of course. Give it a moment to gather its IP number and everything, and let's post some shapes. So now this is one I made before, some random shapes. I send it, and what happened? Didn't work. It says, did I flash it even? I don't think I did. And let's go. That did not work. Bad request. Let's see what happened. Can we have an error message? Well, from that side there isn't really an error. And we're going to go to the post shapes. Was that correct? That was correct. So what's wrong here? We do have an array of there's the rectangle. I didn't implement that one. Let me remove that one. That should do it. Still a no. Oh, now there's this, the trailing comma. There you go. Now we have a few different shapes. So yeah, I think going for that, this construction is really nice and straightforward. Everything is in types, and yeah, there are some clumsiness here and there that you need to, like for example here, that you need to copy paste this thing, which you don't really change. Would be nice if it's somehow easier, but it is nice and robust code. You have to think about all the eventualities. So let me try one more. But it's nice code, and I really enjoy this little device. Having a good time with playing with it. I made another one. Try this one. And with that, I wish you all happy holidays. I hope you enjoyed this episode. As always, let me know if there are things you want to address. I'm working on the MQTT. It has been pushed back a few times. But yeah, let me know. Please leave a like. That really helps motivate, or share, or something like that. You know what YouTube is like. And best wishes for the holidays, and see you next time.